Hello everyone, my name is Ben Crone and in this burst I'm going to be talking about the HIC area calculator. For those not familiar, the HIC area calculator is a primer tool for analysing the many results that are produced during pedestrian head impact. It supports the latest GTR, Euro NCAP and China NCAP protocols, and as part of Oasys 18, it's benefited from several new enhancements. This burst will give a quick refresher of the tool in general before highlighting some of those new features. To open the tool, we must navigate to the safety and pedestrian menus from within Primer. To use the tool, an input file is required that contains the different head impact results. This file is very simple. It's a text file that can be comma, space, or tab separated, and the format is as shown on the slide. It begins with data, and that's for compatibility with Oasys D3 plot. It then has the X coordinate, the Y coordinate, and the Z coordinate of the impact location, the HIC value itself, followed by the name. Names are optional, but they allow for more advanced functionality within the tool. The first letter of a name determines the type. So a C would be a child, an A is an adult, a B or a W would be a cyclist. Now let's go to Primer and demo the tool. So in this example, I've already read in one of those results files. That's what you can currently see on the screen. This would represent half a full set of analyses, so one side of the bonnet or the windscreen. Each of those points is an individual analysis with an associated HIC value, and those HIC values are being used to set the colors that we're seeing on the screen. When Primer reads in this file, it shrink wraps the outermost points using this perimeter black line. On the right hand side, we have the tool itself, so in this floating window, and at the top you can see the button for reading in the data, and underneath there are various display options. So for example, we could turn on or off the impact points, and we could choose whether or not to color by their values. Additionally, there are controls for showing the HIC values, the names of the points, or possibly both. New for version 18 is the Show Plot button, which allows us to toggle the graphics on or off. Moving down the panel, you can see in version 18 we now have a large results table, and I'll come back to that in a little bit more detail later. At the bottom of the panel, we have a series of tabs where each tab contains a variety of settings and features. To start with, let's take a look at the Calculation tab. From here, we can change the various settings that influence the calculations for the different protocols. So for example, the default is the GTR regulation, but we can also choose from NCAP version 8, NCAP version 9, or the China NCAP that was introduced recently. Note that for NCAP version 9, the protocol is currently in draft form and therefore subject to change after the release of this tool. For the GTR reg, you'll see that we have some controls for the perimeter, so we can make that tighter or slacker by clicking on those arrows, and we can control the high and low HIC values. Once we're happy, if we press Calculate Area, Primer calculates an interpolated HIC score between our input points, which is what's shown there. If we wanted to change some of those high and low HIC values, we can do that. So for example, a scale factor might be 0.8, type that in, and the plot will update automatically. If we look at one of the Euro NCAP, for example, you can see that we get inputs for the yellow HIC band, orange HIC, brown and red, and they can be controlled via scale factors also. And down at the bottom here, we have the maximum points available, which is dependent on the reg you choose. So for example, Euro NCAP version 8 is 24, for China it's 10. But you can change that if you wanted to. So now let's take a look at the new results table. And what we have are rows for the different point types, so child, adult and cyclist, and then the columns we have the number of points, the number of impacts and the scores for those impacts. So for example, we have 39 child impact points and we are scoring 13 from the green points. We're scoring 5.25 from the yellows, 7.5 from the oranges, and then 1 point from the browns. If we add those up, we get the 26.75 total. Likewise, 27 for the adults, 13.5 for our cyclists. And then if we sum those up and average them over the whole data set, we have a score out of 10 of 6.593. And if we hover over the blue highlighted section there, we have a full description of the calculation. What we can also do with this new table is add extra points. So what's common is we may, for example, only analyze the cyclists once at the beginning of a project, and then we might not do it for a little while. So they might not always be present in our data set. So if we want to add their contribution, we could do that here. So I can click the little plus and say, how many cyclist points do I want to add? So let's say I wanted to add 10. And I know from previous analyses that those 10 points awarded me with a score of 6. So now, if I hover over here, I now have 41 points for my cyclists. So I have 41, which is 31 plus the 10. And then the score for those is 19.5, which is the 13.5 here in the black plus 6 additional in the red. And now my score has changed from where I was previously to the 6.54 that we see here. And I could do the same for children points or adult points. And if I just take that back off, it returns to the data that was read in. Now let's look at these different tabs. So on the points tab, we have a variety of tools for changing the impact points themselves. So we could edit them either individually or in multiples. New for this version is the ability to edit their names. We can also do some more complicated operations, so we could delete them. We could apply offsets or scale factors to their HIC values. And a new function here is the ability to reflect. So as you can see on the screen there, we've got a positive Y section of our bonnet. So this would be Y0 down the middle. And if we wanted to, we could use this tool to select these points and reflect them about the y-axis. I'll just cancel that for now. We could always restore the blob plot if we make a mistake as well. Over on the Analysis tab, we've got a number of tools for digging more deeply into our data. For example, we've got band sensitivity. This allows us to identify points that are close to changing band, changing color. To use this, we enter a HIC value, so here 40, and we choose whether we want to identify points that are at risk of getting worse, improving, or both. So for example, we choose better or improving. And what prime is shown here is which of the points are within 40 HIC of improving. So yellows to greens, oranges to yellow, and browns to orange. We also have target score. So currently our score is 6.593. If our score was 7.5, we can input this here. And we can also identify points that we may want to exclude from this function. So for example, we may know ahead of time that the points at the top here are very hard to improve. So we can exclude those from Primer's calculation. And here Primer has identified the points that we need to improve to achieve our score. So down in the bottom it says 37 impacts must change band, and the largest change is 224 HIC. So that's that one there, that yellow going to a green. And if we can convert all of those points, we achieve our target. We have similar tools for the GTR regulation, which are grayed out there because we're in NCAP mode. And then for version 18, we've added two new buttons. So Contour HIC is actually old functionality just brought to the front so it can be used more easily. And that allows us to display our interpolated HIC values as a typical contour plot. When we click this button, we get the contour bars here. We can change the maximum in. We could toggle the visibility of those bands, for example. We can hide the contour bar entirely with this new button up here, show and hide contour bar. And then additionally for version 18, we've got this HIC isoplot button. So when we click this, Primer asks us for a HIC value, and the default is the low HIC value used for GTR. We can change that though if we wanted to say 1000. And when I do that, Primer is identifying on our contour plot values of 1000 HIC, so an isoplot. And from within the Utilities tab, you can save out those isoplot points with the button here. Additionally, new for version 18 is the ability to write out perimeters and to read the wraparound lines for both child and cyclist zones. The child wraparound line being subsequently used as part of the GTR child area calculation. We've now discussed the first of those 4 tabs: calculation, points, analysis, and utilities. However, it's this 5th tab, compare, that I'm most keen to show you today. This is a new tool for version 18. It's currently grayed out because we're still in contour HIC mode. So if I turn those off, our compare tab is now active. And all of these tools are designed to allow us to compare between 2 sets of input data. So we need to read a second file. To do that, we go to the button at the top, navigate to our file, and simply read it in. Primer displays the contents of that file in the graphics window as before, and we get a second instance of the tool. At this point, the workflow would have previously been to select the reg we were interested in the second panel, so the China NCAP, and then we would look at the 2 side by side and try to spot the differences. So we might use this Y offset to move our study points over slightly. We could turn off the perimeter, for example, in both of those, and then we would look at the differences. So where things have changed colors, yellow and greens, oranges and browns, and so on. The idea behind this new functionality in the compare tab, though, is to remove that difficulty of playing spot the difference. So how this works is we go into the compare tab, and first of all we choose the data set that we want to compare with. So in this example we've only got one of the data sets, so it's been pre-populated, and that's our baseline blob. And what Primer does is it compares like for like points, and that comparison can be based on the names of those points or the distance between those 2 points, and you can change that distance by typing in a tolerance value here. You can inspect the comparison with this button here. So what this is doing is it's telling me that these blue points have been linked with our baseline set of data by the name, so the N there, and the green points have been linked by their distance, their proximity, so that's the D. And these gray points are baseline data points that aren't present in our study data set. So if we're happy with that, we press OK. And underneath Inspect, there's a number of new tools that we can use to make comparisons between our 2 data sets. Before I do that, I'm going to use the new Show Plot button to hide my baseline data, and I'm going to turn off the perimeter to make it a little bit more clear. The first of the tools I want to show you is the Show Delta tool. So if I click that, Primer calculates the difference between like-for-like points in the 2 data sets and presents those deltas as the text on the screen. The calculation it's doing is study minus baseline, so it's important to get the 2 the right way around. In addition to showing the absolute HIC value deltas, we can also present that as a percentage change. Using the contour delta button, this one here, it's possible to display these differences as a contour plot. So that's what we're showing here, and we use 2 colors to identify the strongest changes. So a dark orange would be a strong positive change, and a dark blue is a strong negative change, where white is the 0 value. So it's very clear where the areas are the HICs are increasing and in what areas the HICs are decreasing. For reference here, we've also got a light dark mode toggle. So I know not everyone uses a white background. We can toggle that such that you get black in the center, which may be more appropriate for your background settings. And the final tool I want to show today is the band change tool. So this is similar to band sensitivity under the analysis panel, where we're highlighting points that have changed banding, changed color. So if I click that, Primer asks me whether or not I want to identify points that have got worse, better, or just changed in general. So if I choose better, we can see that Primer's identified this point has gone from yellow to green. This one is from orange to yellow, brown to orange, and so on. and it's showing the deltas for each of those points. The greys here are the baselines and they're shown for context. We can turn that back off and show worse, for example. So this was a green previously and now it's a yellow in our study, and these points down here, they've all got worse too. So to recap, with our new comparison tab, we can compare two sets of data, a study and a baseline. That comparison is based on the name or the distance, the proximity between the points. We can calculate the difference in HIC values between the data sets, present that as a percentage if we wish. We can contour those differences, and we can also highlight any points which have changed band for the better or the worse. And with that concludes today's demo portion of this burst. I'll return to my slides. So to summarize, the HIC area calculator is a primer tool for pedestrian head impact. The latest version supports China NCAP and draft Euro NCAP version 9 protocols. In this version, we've also added tables of results, tools for changing point names and for reflecting points. There are tools for contouring HIC and calculating ISO points. We now support wraparound lines for calculating child areas. There's added functionality for writing perimeter and ISO point data out as text files. And we've added a whole suite of new tools for comparing two sets of data. Those comparisons include the HIC delta values, band changes, and contouring the delta values. And that concludes today's burst on the HIC area calculator. I hope you found it interesting. If you do have any more questions, please feel free to get in touch with us through any of the means on the slide there. Thank you for your time, and I hope you enjoy the rest of the conference.